Hey guys, Buildzoid here, and today I just want to share like updated thoughts on the Intel 13th Gen, 14th Gen instability situation because there's new information that has come out from like Wendell at Level 1 Techs, and also there was this video from Hardware Unboxed, which was the first video because like basically when I made my experimental fix, I didn't want to believe that there was CPUs degrading because like that is like I had been hearing like, sort like yeah, I'd been hearing about like, oh, it's kind of easy to break 13th gen, 14th gen from like when overclocking. Um Even at like voltages that I would have considered very much in like the safe zone. And I just kind of didn't really give that a lot of weight cuz it just didn't like it just didn't make sense to me. Like historically, Intel CPUs have been pretty resilient, and then again, this is like the first time in like age. Like this is the new manufacturing process for Intel, right? Like keep in mind with 14 nanometer, there was Broadwell, Skylake, Kaby Lake, Coffee Lake refresh, Comet Lake, Rocket Lake, right? So Intel had like all of the time in the world to perfect 14 nanometer and find the absolute limit of what that manufacturing process is capable of dealing with. Whereas basically we have 12th gen and then we go 13th gen, right? Because 14th gen is just 13th gen again, except souped up, probably too souped up. Um, so um, Yeah, so actually the whole like, oh, it like CPUs don't degrade is like, well, they shouldn't degrade. Like even like you can take like random 10-year-old CPUs and most of them work just as well today as they worked 10 years ago. Um and so yeah, for me like I didn't want to believe that CPUs could be degrade like there were CPUs rapidly degrading out there. Um because that would have been like I could like so yeah, I didn't want to believe that there was degradation, but at this point like they're like Hardware Unboxed was like the first to basically confirm in a what I would consider like official-ish capacity that yeah, like there's CPUs degrading out there. And then there's this video from Wendell where it's like, "Oh man, these things are degrading in very large quantities and very quickly." Um so yeah. Anyway, so basically, let's go through this. So there's sort of two issues, right? What my experimental fix was meant to address is the fact that you could buy a brand new in-box high-end Intel CPU, stick it in your motherboard, and not be able to run Cinebench. Or not be able to run Unreal 5 games. Or is it Unreal 5? I don't know which engine. Like Unreal Engine games. Like yeah, you wouldn't be able to run them because the CPU wouldn't be stable in all core workloads. And the reason this was happening, and or maybe even like I don't know if you didn't like there are now BIOSes that are supposed to address this, but like if you don't have one of those BIOSes, then like it could still be happening for you. But anyway, so the reason why that happens, where it's like yeah, you get a brand new factory sealed CPU. There's no way this thing degraded because it was never like it has as little runtime as a CPU could really have, right? So I would say we can safely assume that the CPU hasn't degraded yet because it hasn't been used yet. You put it in your motherboard and it crashes. And the reason this happens is because the motherboard vendors were basically using the AC load line setting to apply undervolts to the CPU. Um, what the AC load line setting is supposed to do is it's supposed to inform the CPU about the load line settings of the motherboard's voltage regulator so that the CPU can adjust its vid requests to match the load line of the motherboard's voltage regulator. Now, basically what Asus and Gigabyte, like I think MSI might have been doing this as well, but maybe not as much to a degree, and I don't know about ASRock, but both Asus and Gigabyte would basically set the AC load line uh so that like they would set the AC load line really low. So to like really shallow. So like Gigabyte was using 0.4 milliohms for a lot of CPUs. Asus was using 0.5-ish milliohms for a lot of CPUs, and the motherboard would actually be running a load line slope of like say 0.9 or 0 or more, right? And so what would happen is basically the CPU would send this would send vid requests that were lower than they needed to be, because the CPU thought that there was less VDROOP than there actually is. Um, and so the thing is, like, yeah, your CPU would like boost higher and you'd get better performance, somewhat better, like better efficiency, but it wouldn't be stable because it was not getting like enough voltage to be stable. So that's what my experimental fix was meant to address, because basically, the way Intel wrote their motherboard design guidelines encouraged the motherboard vendors to push the AC load line as low as it goes. Um, and Intel doesn't actually check the work that the board vendors do, like at all, apparently, which was confirmed, like according to, like based on Hardware Unboxed. That's like based on Hardware Unboxed videos, but also I like based on the whole situation. I can't imagine that Intel did any like. What more confirmation do you need that they don't do validation other than this entire mess being a thing? But anyway, yeah, so the motherboards would basically apply a undervolt by setting the AC load line like to not match the actual VDROOP of the board. And then your CPU would crash because it wasn't getting enough voltage, even if it was brand new and definitely hadn't suffered any degradation yet. And so that's what my experimental fix was meant to address. Um, and yeah, and since then, like Intel's put out a whole bunch of stuff to sort of like fix that. There are now BIOSes from like Asus and Gigabyte, which are like add like new, because there was like the whole Intel baseline profiles, and Gigabyte's Intel baseline profile was super bad. That apparently got taken down due to the video I made about it. Because anyway, so yeah, so there's like now new Intel like performance what is it? Intel default settings. Yeah, and this is apparently like more Intel specky. I don't know. Like hopefully Intel is actually involved in whatever the Intel default settings are, and it's not just Intel letting the motherboard vendors try to fix the problem themselves. Because like the here my whole issue with this entire situation, like with the default settings being a mess, is like Intel designs these CPUs. Like the motherboard vendors don't make the CPUs. They don't know the validation that Intel has. Like, how are they supposed to know what? Like, it's ridiculous. Like Intel is supposed to basically tell them, hey, this CPU, like we designed a 14900K at 6 gigahertz. It needs this voltage and this load line. At 5.8 gigahertz, it needs this voltage and this load line. You know, and like just go through and that's just like anyway. So yeah, but also there was a patch to deal with some like ETVB bug. Um, I'm not sure how relevant that is to this situation. According to Intel, yeah, it's like not, but no final solution to instability issues. Um, anyway, yeah. So as far as I can tell, the situation of like I bought a brand new CPU, I put it in my high-end motherboard, I tried to run Cinebench, it locks up. That should be solved at this point. Because the motherboards are no longer gonna be like setting the AC load line in a way that undervolts the CPU, because Intel now like just straight up requires like, hey, like you need to turn CEP on. And if you turn CEP on and you try to undervolt by messing with the AC load line, the CPU will clock stretch like crazy because it will get very upset about there being like a mismatch in the voltage that it expects and the voltage that it actually gets. So yeah. So that's that. But that's a separate issue from basically what like Wendell found and like the degradation thing. Um, so yeah, so that's the first thing I want to point out. Like my experimental fix is not meant to, like I do make some suggestions in there for like, hey, like maybe try lower the temperature limit, disable the 6 gigahertz boost so that the CPU doesn't go into the silly end of the voltage table. The voltage table is provided by Intel, by the way. That's not on the motherboard vendor. And basically, my experimental fix, like my entire focus the entire time, was to just get the average voltage as low as possible. Because that's what's going to cause the most damage to the CPU. Is if your average voltage is high, then the CPU is going to, like, if the CPU is susceptible to degradation, then you want to keep the average voltage as low as possible. Because, yeah, like your other option is to just run it at very low frequencies in order to maintain a low average voltage. And the reason I mentioned that is like I do run a very aggressive LLC that has like noticeable overshoot, but my thought process behind that with this video was like, well, I'd rather have overshoot with an average voltage of 1.3 volts or like 1.4 volts at idle than an average idle voltage of 1.5. Okay? Like, occasional overshoot to 1.5 volts is probably less of a problem than averaging 1.5 in low loads, right? Was sort of my thought process. Now, I could be wrong about that. But yeah, that's my thought process on why I'm running that extreme LLC setting in this video. Anyway, so yeah, so I do offer like, if you disable the 6 gigahertz boost, that'll bring down the maximum voltages that the CPU sees. Also, once you disable the 6 gigahertz boost, depending on your E-core vid, you might want to actually lower the E-cores as well, because the E-cores could potentially end up requesting higher voltages than what the P-cores do, which is just stupid. And also I suggested like, lowering the max temperature limit. But the thing is, Wendell, went through those data center CPUs that were degraded. Like, he found a bunch of data center CPUs that were degraded, or not really data center, but like server CPUs that were degrading. And apparently, like, those CPUs never went over 83 degrees Celsius. Right? So my suggestion of like, lower your TJ max to like 90 or 95 instead of, because by default, 13th gen, like 12th gen had a TJ max of 95 degrees Celsius, 13th gen and 14th gen have a TJ max of 100. So my suggestion of like, lower that to like 95 or 90, yeah, that's not going to do anything if Wendell found a bunch of CPUs that are degraded and have a max operating, like, that never went above like 83 degrees Celsius. Like, yeah, lowering the TJ max is just not going to do anything in that scenario. So, yeah, like, this really wasn't meant to be like, if, like, my thought process was like, if there is degradation, then at least, like, trying to minimize the operating voltages of the CPU should help, right? Like, should help. But this wasn't really like, I'm doing my best to minimize the possibility of degradation on the CPU. This was like, I wanna just primarily fix the instability, where it's like, the voltage is too low, and I want to do it without, because the thing is, there's sort of two ways you can fix the out-of-box instability on a like brand new CPU. One, you can do what my experimental fix does, and two, and this is the easier thing you can do, you can just set the AC load line really high, and then you get extremely high idle voltages. But also it's stable, right? So yeah, and I didn't want to, like, here's the thing. At the time that I was making this video, I was hearing rumors of like, hey, these CPUs are degrading. I didn't want to believe that. Like, I really didn't want to believe that, because that's just like a massive validation fail from Intel, as far as I'm concerned. Like, the CPUs, like, unstable at stock because the voltages are set too low, cool. But degrading when motherboard vendors are randomly undervolting your CPUs, so these things are running at less voltage than what you expect, to the point that they're not even stable out of the box, and they're degrading at these lower voltages? What are you doing? Yeah, so yeah, at the time of making this video, my thought process was like, look, I am not going to suggest a stability fix that boosts the operating voltage, because if these chips are degrading, that is the stupidest thing you can do, because that'll degrade them faster. So they might work for like a week or maybe a month, or like, I don't know how long, because degradation is kind of random. Like some CPUs degrade really slowly, some CPUs degrade really fast. But yeah, so I didn't want to make any suggestions that were like, hey, if there is degradation, I don't want to make it worse. So that's why like my fix for the instability is actually extremely complicated, because yeah, you could fix it by just raising the voltage, but that seems like a really dumb idea. So anyway, now then, onto the degradation stuff. So yeah, watch the level 1 text video. But my main takeaways was like, these are, data center CPUs running on motherboards like this. And this could probably do like 200 watts in terms of power delivery. Like, if you throw enough airflow at this, this can probably do 200 watts. Even more than that. Like, I got a 6-phase VRM to do 230. It wasn't fun. I needed like a 9,000 RPM fan to do it, but it can be done. And yeah, and then this board, like this could actually easily do 250 watts. I see absolutely no reason that this couldn't do 250 watts in a server environment where you have a ton of airflow. Yeah. But regardless of that, like Wendell said that he didn't, like the highest temperature these CPUs were hitting was like 83 degrees or something, which is really low. And the other thing he noticed is that like there's a lot of I/O errors. It's not just like core errors; it's like I/O errors. Also, like some CPUs, like in order to fix them, because he tried fixing some of these machines, like some of them you could fix by disabling E cores. Some of them it's like, oh, there's like a P core that you need to disable to fix the stability. Some of them you have to disable hyperthreading. Some of them you need to underclock, right? Sometimes they'd need a mix of things. And sometimes there'd be some CPUs that no matter what you did, they just wouldn't be stable anymore. And so this combination of like low temperatures, probably not insane power limits. I imagine Supermicro probably wasn't trying to intentionally like mess with the AC load line to get the CPUs running, faster. Supermicro probably also wasn't disabling things like CEP, right? And all of that. And like turning on the unlimited current, like the current limit disable bit. Like Supermicro probably wouldn't turn that on. Asus maybe yes, but Supermicro probably not. And like there was unstable Supermicro systems, unstable ASRock systems, unstable Asus systems. None of them were running super ridiculously hot. This is a server environment, so they're not running like XMP profiles or anything. And oh yeah, some CPUs would get stable if you like massively drop the memory speeds. And so, like, you have like these random mix of fixes. The errors are random, like they're not consistent. Like some, you have I/O errors, CPU errors, like memory errors, everything, like errors everywhere. And so after watching this video, it's like, well, this video was like, okay, there's degradation, and this video was like, oh my god, there's a lot of degradation, and it's like random. Because, like, my initial thought was, like, if there is degradation, it's probably the 6 gigahertz boost that's doing it. So it's, like, wrecking the best 2 P cores. Is, like, those 2 P cores that run 6 gigahertz on your 14900K, those get degraded first. That was my thought process. So every CPU where the degradation occurs, you would be disabling the P cores first. But, like, Wendell was fixing CPUs by turning off the E cores. Now, admittedly, turning off the E cores reduces the like power, like somewhat changes the loading on the power delivery, but like these things aren't like, these chips are hitting 83 degrees max. I can't imagine that they're actually hitting 100% load. Not to the degree that the E cores would be dragging the voltage down by a significant amount. Or like And actually, you're on dynamic vid, so the CPU should be able to compensate for that itself. So, like, turning off the E-cores is like, okay, that doesn't really match my theory of, like, the 6 gigahertz cores degrade first, and then, like, at all, like, because you wouldn't, like, turning off the E-cores? What? Why are the E-cores degrading? That doesn't make any sense. But see, the E-cores, the P-cores, they're connected together with the ring. Right? The ring and the L3 cache connect the ring is like part of the L3 cache, and the ring connects the E cores and the P cores together. And the ring and the E cores and the P cores all share the same power rail. They all run on V core. And so the thing is, when a P core on your 14900K requests 1.5 volts in order to hit its 6 gigahertz boost, that 1.5 volts gets applied to the ring and also all of the E cores. But I would imagine in a 6 gigahertz boost scenario, the E cores are probably parked or like in some kind of deep sleep state, because like 6 gigahertz boost is like single threaded, like is for like up to 2 threads max, right? So like the E cores really shouldn't be doing anything, because like yeah, at least that's my assumption on how that behaves. So I can't imagine that like the 6 gigahertz boost applying 1.5 volts to everything would be breaking the E cores, because the E cores probably aren't actually on in that scenario, but the ring is. So maybe it's not, the P cores breaking or the E cores breaking over time. It's actually the ring falling apart because of the very high voltages that the P cores request sometimes. And that leads to the I/O errors, right? Because the ring is what connects the cores to the memory. That's what creates all of your like why some CPUs you disable E cores to fix the instability, which makes zero sense. But yeah, like if the ring is falling apart, maybe the part of the ring that like you could break the E cores without actually you could break the connection to the E cores without actually having the E cores under any load. Is my theory based on, like Wendell's findings. And so yeah, that's sort of my new thoughts on this. Is like, okay, so like I thought it was like, oh, the best two P cores are just like burning themselves up at 6 gigahertz. But now I think it's actually the best two P cores are burning the ring to the ground with their vid requests. And speaking of the vid requests, like I really wish I had voltages for the 12900K, because like 12th gen seems to not be affected. Also, the other reason why I'm so into the like voltage side of this and the vid tape, like vids, is because there's this pie chart from the developers of Warframe showing NVIDIA GPU driver crashes by CPU. All of the NVIDIA GPU driver crashes that they get. So, yeah, while investigating crashes in Warframe, we came across a particular series that were not crashing in our code. They were crashing in NVGPU Comp64DLL, a component of the NVIDIA drivers. Aggregating hundreds of reports from helpful players, we discovered a pattern. Almost all were coming from systems with 13th and 14th gen Intel CPUs. Right? And if you look at this pie chart, what you'll notice is most of it is actually just i9s. And what is the difference between i9s, i7s, and i5s? The voltages. See, i9s, in order to reach 6 gigahertz, run anywhere between 1.5 and 1.4 volts. And most of them don't run 1.4 volts because most of them are not good. Right? Most of your i9s are somewhere around like 1.45-ish in this area. And here's my CPU. My 14900K review sample from Intel. Yeah, it's a 1.498 vid CPU. They really went fishing through that dumpster behind the fab when they were looking for review samples to send me. And then there's also the like 1.5 volt chips. Now, the funny thing is, the vid tables aren't set with the same safety margin across all CPUs. So, like, some CPUs will have more safety margin than other CPUs, even if they have the same vid reading. So, this isn't the end all be all of, like, silicon quality, but it is the end all be all of what kind of voltages the CPU is going to request under operation. Because the way the vid table works is like this is the voltage the CPU will request, assuming that the load line is 0, which it isn't on any real world motherboard because real world power planes do not have 0 impedance. That is physically impossible. But, or I should say, real world power distribution networks don't have zero impedance. That is physically impossible. But yeah, if you had this perfect power distribution network, the CPU would request 1.503 volts in order to reach 6 gigahertz. And obviously, if your AC load line is higher than 0, then it's going to request more voltage. In theory, that voltage should then droop to the appropriate voltage by the time it actually reaches the silicon, but yeah. So basically, these CPUs are just like the i9s just have insane voltages. If you look at the i7s, and I don't know why I have i9s open again, but let's open up the i7s. So if you look at the i7s, what you'll notice is that they top out at like 1.43. So basically, the very best i9s are running the voltages that the very worst i7s do, right? Now the i5s are kind of wacky because the i5s just suck. Is this the i5s? Yeah, this is the i5s. So the i5s are just completely all over the place, but hey, they're at least under 1.4 volts. But like they're really like you have 1.4 volts at one end, 1.2 at the other, right? Massive range. But still, this is like okay, like if we look at our i7s, where is it? Anyway, yeah, so your very best i7 is like about as good as the like or in terms of voltage is like an average i5, right? So, but the worst i7s are like um some of the best i9s in terms of voltages. And then if you look at the chart for Warframe here, it's like, yeah, so we have like a small percentage of i7s, causing a lot of errors. And I would think the i7s are relatively popular CPUs compared to like, because you also have like, oh, there's like a KS over there and KS over here, right? And the thing with the KSs is I think the reason there's so few of them is just because they're rare. Um, but the i7s, I would assume like I don't think it's realistic that the i7s would be like more like significantly less common than the i9s. That just doesn't make any sense. The i7s are so much cheaper than the i9s. I would imagine the i7s probably outsell the i9s, right? I think it would be very weird if they didn't. Um, Even though it feels like every Intel user I ever talked to has an i9. So I don't know about that. But that might just be my biased like audience side. Like that might just be because of my audience, right? Like anybody who watches my channel and has an Intel CPU, like it's either like if they have a current gen Intel CPU, it's probably an i9 just because they're in my audience. But I would assume that in the real world the i9s are probably less common than i7s. But in this chart they do seem kind of massively overrepresented. And I think that's because they just run insane voltages. So if the ring is like fragile and susceptible to degradation due to high voltage, well, the i9s are going to be the worst at it because they run the highest voltages. Right? So, yeah. And the funny thing is, even for the all core frequencies, like you can get some CPUs that have some very high vids. Like over 1.4 volts. Like I think the chip I have is like one. It's not massively over 1.4 volts if I'm not mistaken, but it's like it's bad. Like that's actually the funny thing is I've seen CPUs with like the 1.5 6 gigahertz vid and then a better 5.7 gigahertz vid than what I have. Um, so yeah, I have just an absolute potato of an i9. Um, Also, it's not stable, but you know that's just a given, I think. Or well, actually, like after with the experimental fix, it is stable, but yeah. And I don't run it enough to degrade it because I think I run like a few hours of like memory stress tests and admittedly some Y cruncher on it, which is very heavy, but um, I have actually been setting a power limit on the thing. When usually when running Y cruncher, like I haven't been running it flat out. Um, so I don't like it might have degraded a little, but I don't think that much. And I really don't use that CPU very much because yeah, it's not good. I don't like it. So anyway, um, I mean it's really good at getting high scores in benchmarks, but it's like not a CPU I enjoy using for anything else. And honestly, I don't even enjoy using it for benchmarks because it's just like it's not like an FX CPU where it's like, well, it's cheap on eBay and it's just dumb fun. It's like, no, this is a really really expensive CPU and the only thing it's good for is getting high scores in 3D Mark. Um, it's almost as bad as like how I feel about the Threadripper 3000 chip that I have, where it's like, man, this thing is only good at Cinebench. That's worse. Um, but anyway, um, yeah, so like this as far as I'm concerned, the reason this chart is like 75% i9 CPUs is because the i9s just run way higher voltages than the i7s. And there's some i7s in there because the i7s still run pretty high voltages, right? Like 1.43, 1.428. And like I don't think okay, they had a lot of these. Yeah, so they had 152 i7s whereas they had 224 i9s. So I guess there's a relatively small chance that they like I don't know, like there might be even worse i7s. There could be even worse i9s. I mean, I know that KS chips go all the way up to like 1.55 volts or something for their 6.2 gigahertz vid. So I imagine if the ring is susceptible to voltage degradation, man, the KS chips must be like oh boy. Anyway, yeah. So that's why I think this looks the way it does, where it's like, yeah, this is all i9s because i9s run just the highest voltages. Um, and then you have the i7s because the i7s still run pretty high voltages, but there's like no i5s, at least not in any. Yeah, like there's no i5s here. Like this i7 14700KF being listed twice. I'm wondering if that's a typo and it's a 14600K up there, but because the 14600K is actually like, I mean, it's like if my theory is correct, like these chips up here might be susceptible to degradation. Maybe, maybe not. I don't know. Like the i5s also run lower frequencies, so maybe that would actually help or something. Um, or because they run lower frequencies, it takes significantly longer before you see the degradation, like cause errors. Um, so yeah, I am not sure on that. But yeah, like that's my theory at this point. Like after watching Wendell's video, because initially, like I really didn't want to believe that there's degradation going on. Like botching the voltage, like the power delivery configuration, because the guidelines are loosey goosey from Intel. Sure, I could see that being a problem. And then you'd get brand new inbox CPUs that aren't stable. But now it's like we have with Wendell's video, like solid evidence that these chips just disassemble themselves, even in rather mild operating conditions, in my opinion. Right? Like these chips are maxing out at 80 degrees in these server setups. They're not running XMP, and they're degrading rapidly. Um, and it's a lot of them. Like, watch the video if you want to find out how many. Yeah, I'm not like, I do feel quite bad about just like ripping off other people's information, like this. But yeah, and then like also the hardware unboxed video. This doesn't really go into a lot of detail on what exactly is happening or why, but into how like Intel is not dealing with it basically. Um, and yeah, so that's like my new thoughts on what's going on with the degradation, which is separate from the like, hey, you can buy a brand new CPU and it won't be stable. Well, you can buy a CPU and it'll be stable, and then 6 months later, it isn't anymore. And I think the reason that's happening is probably because the ring is falling apart. Because the thing is, like, it's i9s and then it's i7s, but I don't see any i5s. And the i5s run way lower voltages. And the core voltage is applied to the ring, the E cores, and the P cores. So, like, like or like the CPU degrades if too many of the E cores are turned on, which would be the stupidest cause of like that doesn't make any sense because the 13700K has just as many E cores as a 14600K i5. So that wouldn't actually make any sense if like having too many E cores would break your CPU. But having too high core voltages would break the ring. Oh yeah, yeah, and the thing is, I've heard from overclockers that like they've broken the ring on their CPUs. But again, that's in an overclocking environment, so I didn't give it a lot of weight. Where it's like, you're running like 5+ gigahertz ring clock, whereas out of the box the CPUs run like 4.8 or something. Um, so it's like, you know, and I don't really consider that as counting, but it's like now we have like these are chips in servers that are just like falling apart. Um, and it seems to primarily be i9 CPUs. So I'm going to go with it's probably the voltage. Because if it wasn't the voltage, it would be everything, right? It would be i3, like anything Raptor Lake would be susceptible to just not being stable. But this is all i9s and i7s. I think Wendell, like, it could also, like, the server population, I would assume, is primarily i9s. Because the whole reason that you would put, like, consumer CPUs in a server is because you want the single-threaded performance. And the i9s are the best single-threaded performance Intel offers. Yeah, there's this game studio that basically has said that, like, they're migrating all of their stuff to AMD now because they're just sick of dealing with Intel CPUs. But yeah, I don't know like if they have any i5s. I assume not because like they're like a high end like yeah if they're yeah I would assume this is all i9s i7s again. i7s being less affected because of the lower voltages. Um, As for if, like, here's the thing. If I am correct that the issue is the ring cannot tolerate the voltages that the P cores are requesting, um, then basically the only fix that I can see for this, as like, and like the thing is, I've never designed a CPU. I've never worked at a CPU manufacturing company. I am entirely like, you know, like not. I'm not really qualified to give an opinion on this, but like I don't see a way that Intel can have a 6 gigahertz boost clock and not have the insane voltage that it requires. Right? Because like you can either have the CPU run at 6 gigahertz or you can have a low voltage. You can't have both. So from my perspective, at least as far as I know, you can't have both. I don't know. Maybe you can like insert NOPs between your between your when the CPU is running at 6 gigahertz, you just put NOPs in between your instructions, and then it's like actually it's doing like 3 gigahertz worth of work, but at least it says 6 gigahertz in the frequency monitoring software. Um, but yeah, so like I don't know, but like so I don't know if there's any like weirdness that they could do to like like get around the whole like, hey, in order for the CPU to run at 6 gigahertz, we need over 1.4 volts. And if there isn't, then like, well, the only fix for this is like you lower the boost clock. Potentially quite a lot, right? Like you would probably like the i9s, I would imagine you'd be shaving off like 500 megahertz to get the voltage under control. Um, at which point the i9 becomes significantly less competitive with, say, a 7950X. Um, and then the i7 is like, I don't think the i7 would need to get shaved off because basically with the i7, I think you'd basically want to take the chips that are up in this end, which is admittedly most of them. But yeah, you'd want to take like the, or maybe just the out, like the ones that are at the very top of the range. I don't know, and like just try to push them down a bit. The other issue is like the CPUs that run at these lower voltages, like they're probably just like they might not be degrading because like all silicon degrades over time, right? But there's like noticeably degraded after 10 years, noticeably degraded after 5 years, noticeably degraded after a year, noticeably degraded after like 6 months, 3 months, 2 months, a month, a week, an hour, fraction of a second, right? If you apply 2 volts to a most modern silicon, like 2 volts V core, because there are other parts of the chip that would actually, like the VCCN rail for 14th gen is 1.8 volts. So yeah, you put 2 volts on that, that's fine. But you put 2 volts on V core, honestly, I would be surprised if that CPU manages to post, because I would imagine it would disassemble itself before it gets through the post process. It would revert back to sand most efficiently. Um, but you know, so like that's the thing is like you have a range to how quickly the degradation can happen, and so it might be that the i7s just aren't degrading fast enough to be showing up often right now. Um, but I would imagine like I like the thing is I don't have a like I unfortunately don't have this kind of nice data from Igor's lab about the vid voltages for 12th gen. If I had this for 12900Ks, because like maybe Intel like drastically changed something about the design of the ring, which they probably did because the ring, like 12th gen, the ring interconnect maxed out. Like if you didn't turn the E-cores off, it maxed out at like 4.2 gigahertz or something. It clocked like garbage. And if you did turn off the E-cores, it could clock to like 4.85 gigahertz. Um, Whereas with 13th gen, 14th gen, the ring clock now goes all the way up to 4.8, even with the E-cores. Actually, it doesn't even matter if you have the E-cores turned on or off anymore. Like you can clock the ring as high as you like, as high as it'll go, regardless of if the E-cores are disabled. Um, so that's a pretty significant design change there. But I don't see any immediate reason that that would like make the ring drastically more like again, not a CPU architect. And it is a thing that, like, even on the same manufacturing process, different designs will have different voltage tolerances. But it just doesn't seem reasonable to me that, like, Intel would have, like, changed the ring design in such a way that now it tolerates, like, 200 millivolts less voltage or something. Right? Like, that just doesn't really, like, what? That doesn't make sense to me. Again, not a CPU architect, so like it not making sense to me doesn't really mean much. Um, but I would imagine that's not the kind of thing you would do intentionally in your design, and it's probably something you could catch. I would assume, right? Where it's like, yeah, like so, yeah. So I don't know about that. And the main thing I'm wondering is like, well, do 12900Ks run at voltages that are like how like what kind of voltages does a 12900K typically run? Because I unfortunately don't have a 12900K on hand anymore. Um, and also the one I had wasn't particularly great, which actually probably would have been a good thing for figuring out what the upper end of the vid table is. Um, But yeah, like I don't know what the vid table for a 12th gen looks like typically. Um, if it looks similar to an i7, then I guess that's why we're not seeing a bunch of failing 12th gen CPUs. It might be lower than the i7s. Like I don't know. Um, yeah, like I actually just don't know what the 12900K vid tables look like. Um, I still think they were still pretty aggressive. Like I do think they go into the 1.4 range. I don't think they go into the like 1.5 because I don't think even most 13900Ks get into the 1.5 end of the voltage range. Um, Unfortunately, I don't have vid tables for 13900Ks either. So, yeah, that's my current like speculation on the situation is just like it's probably the ring and it's probably because of the voltage. And if it is because of the voltage, then the only fix is to slow the CPUs down. At least as far as I know. Like that's the only thing like that's the only fix I am aware like I can think of where it's like, yeah, you drop the clocks and drop the voltage. And probably refund people for all the performance they just lost because you just lowered the frequency by like 10% or something. Um, right? Like I'd feel pretty bad if my CPU randomly got 10% slower after I paid for it. In fact, like the 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 one major issue I had with hardware. Actually, there's two cases. I had a Rampage 5 Extreme, which was, as far as I'm concerned, the worst experience I've ever had with a motherboard. Um, like even when I got my replacement from RMA, I just sold that board. I did not use it. And then my very first GPU was a GTX 590. It was really unreliable and led to me not running NVIDIA GPUs in my daily system for basically until like after Navi release, around Navi really, basically until NVIDIA 30 series. Yeah, something like that. 20 series, 30 series. Um, I was absolutely no NVIDIA GPUs in the daily system. Um, so yeah, and this right here is like, yeah, this is like I would consider this on the level of the GTX 590. Um, cause like this, like, and what bugs, like, you know what kind of annoys me about this is like nobody was for. Well, okay, I guess the issue is like, you know, if Intel didn't run the 14900K at 6 gigahertz, it would get smacked by the 7800X3D in games even harder than it already does. Um, but at least you would have a CPU that doesn't break after 6 months of stock settings, right? Like, and the thing is, like, the things that the i9 is good at, like, where, like, because there are games that, like, an i9 is just better than anything AMD makes right now. Um, Even the 7800X3D, like, there are games that just don't fit in the L3 cache. Even if you have a lot of L3 cache, they still don't fit. Or you have games that just are so small that it doesn't matter if your cache is massive, and it's more important that your CPU can run higher frequencies, right? And in those kinds of games, even at 5.5 gigahertz, a 14900K is going to be better than like a 7800X3D or a 7950X because, as far as I can tell, AMD's instructions per clock, at least in gaming, don't really seem to be on par with Intel yet. Like, I don't really consider 7000 series to even really rival 12th gen Intel. Like, 12th gen Intel doesn't clock very high, it tops out at like 5 ish gigahertz, right? Whereas like Ryzen 7000 goes to like 5.7 if it's not really doing anything, but more like 5.5 if it's actually under load. If we're talking about the 7950X, right? And so like where Intel, like basically places where Intel already like is doing well, it doesn't really matter if they're at 6 gigahertz or 5.5. And places where Intel is doing badly, it also really doesn't matter if they're at 6 gigahertz or 5.5. Um, and so sure, yeah, the out of box CPU would be somewhat slower, but at least this probably wouldn't be happening. Um, so yeah, that's my like that's my thoughts on this. Is like I really, when I made this video, like the experimental fix, like I really didn't want to believe that these chips are degrading, but at this point, like I'd say this is like irrefutable evidence that these chips are just rapidly disassembling themselves. Um, and like my uneducated, you know, like guess for how you could fix this is just don't set the voltage so high, which means you can't run them at 6 gigahertz. And that's probably why Intel doesn't want to talk about it. Right? Like that's my guess for why Intel has been like completely silent, like really not helpful about this entire situation for like several months now. Like this has been going on forever. Right? Like Nvidia called Intel out on like, hey, if you get Nvidia driver crashes, they're not actually Nvidia driver crashes. It's your Intel CPU feeding garbage data to the GPU, and the GPU getting very upset about it. Um, so, or actually, like the funny thing is, NVIDIA's driver actually runs, like, NVIDIA's driver runs on your CPU, right? So if your CPU is unstable and it scrambles the NVIDIA driver, well, the NVIDIA driver is going to crash. If it scrambles like some game assets, the game is going to crash. If it it scrambles the Cinebench rendering data, Cinebench crashes. And just like that's why the crashes are just like random software, and random is just like because yeah, it's just going to affect whatever the CPU is doing at the time. Oh, you're saving some files? Oh, there's errors in them. Oh, you're writing data, like you're moving data to the GPU. Oh, there's errors in that. Um, like, where was I going with this? Uh, yeah, so like this has been going on for a while, right? Like Nvidia like had that blog post about like, hey, it's Intel. And Intel has basically made no progress. They seemingly, yeah, like they haven't made any big official announcement. And my guess at this point is that the only thing they could announce is like, yeah, we are retroactively slowing your CPU down by 10% or something like that. It might not be quite 10%, it might be less than that. But I think, yeah, it might be like, yeah, you were just going to like slow your CPU down by 10%. You're not getting a refund. Um, or at least they really don't want to give you a refund. They like, hopefully they have to, because this is ridiculous. Um, But that's my guess for why they're being so quiet about it is because like they and the thing is like cuz somebody like asked me like why now, right? Why hasn't this happened sooner? Well, with 14 nanometer, right? Intel had forever to figure out that manufacturing process, right? You had Broadwell, which sucked. You had Skylake, which was pretty good. And then you had Kaby Lake, which basically took Skylake and clocked it harder. And then they made Coffee Lake, which added some cores and clocked higher. And then they had Coffee Lake Refresh, which was the first Intel CPU to run 5 gigahertz boost. Also, it had 2 more cores. And then you had 10th gen, which went a little bit past 5 gigahertz. And then you had 11th gen, which sucked, but also, like, you know, yeah, it's, but like, it was a thing, um, and it, like, I don't think it degraded or anything. So yeah, like with 14 nanometer, Intel had years to figure out, to like basically creep up onto the limits of the manufacturing process. And with 13th gen, it was just like, yeah, 12th gen was pretty good. Let's just like raise all the voltages, and then for 14th gen, raise them again. Um, and as it turns out, that seems to have not been the best idea. Because the thing is, with like 14 nanometer, that was also a thing. Like the voltages kept getting progressively higher over time. Um, and yeah, but like now they tried to do it in like a like just go from 12th gen to 13th gen, 14th gen. Um, and I'm not even sure if they like did it too fast or just like pushed too hard. Like I really wonder what kind of like reliability test data Intel has for like 13th and 14th gen. Cuz like 13th gen's been out for like ages now, right? Oh, it doesn't say when it launched. Oh wait, no it does. In 2022, 21, 14th gen was 23. Yeah, so they had like a year of 13th gen. Like they could have manually degraded 13th gen CPUs in the lab at this point. Right? And that probably would have been a good idea to like just have a few of these chips roasting away somewhere in a warehouse so that cuz like technically you're supposed to do it before you release the product, but just in case, you might want to check. um so I would really hope that Intel just like they know what's going, like at this point they'd have like know what's going on. Um Because yeah, like they've literally like 13th gen's been around for a year. Like they could have literally just like had a warehouse with like 100 13th gen systems just crunching away. Though no, because the like again Wendell like super micro boards are apparently unstable with Intel i9s. Um, and I would imagine like this is the funny thing is because Intel's guidelines are so loose. It's like, well, what if Intel has like their own internal like stress test boards and those run completely different settings from what they're actually shipping, right? That would be one way that Intel could be completely clueless as to what is going on, is if they internally tested with completely different settings than what they're actually like what the end users actually receive, which would still be a massive freaking failure. And I don't think that's that likely. Um, there has to be some retail motherboards that actually like behave the way Intel intended. Though Intel doesn't really seem to be very good about telling us what it is that they intended. I mean, I'm assuming they didn't intend for the chips to be falling apart after a few months, but here we are. Um, yeah. So that's like my thoughts on this situation is just like I like my fix was not meant to deal with degradation, so I would not like it. Yeah, like if your CPU has degraded, I would try to get it replaced well, honestly, if it was me, I'd sell the replacement CPU and the motherboard and just like swear off Intel CPUs for like a few years. Like you screw me over by selling me defective trash. Like I'm not buying stuff from you anymore. Like that's what I did with Nvidia. Like I literally didn't buy Nvidia GPUs regardless of how many freaking driver problems I had with AMD because with the one Nvidia GPU I had, like that thing was like a hardware fail. Um so yeah, like anyway, so I hope like this is such a like I don't man, this is such a dumb situation because like the 14th gen CPUs, like they're like the fundamentally like they are fast. Okay? There are workloads where an i9 is just the best thing you can have. Even at 5.5 gigahertz, it's still the best thing you can have. Um, but it had to be 6 gigahertz. It couldn't have reasonable safe settings out of the box. It had to be redlined to the limit so that it could slightly lose to a 7800X 3D anyway. And like the 7 9 like for multi-threaded like it kind of depends on the workload as far as I know. Like there's some stuff that really likes AMD and there's like some workloads that really like Intel for multi-threaded. Um And you're not even using the 6 gigahertz boost in multi-threaded. Hell, you're not even using the 5.7 because the CPU hits TJ max before it like and throttles down to like 5.2, 5.3 in my experience. Like if you have like a 360 millimeter AIO, your i9 is probably going to run at like 5.3 gigahertz in my experience. Admittedly, my i9 really sucks, so I don't know. Maybe the better ones run at like 5.4. But they don't run at freaking 6. So like, because that's the thing is like Intel could have easily like it would have been so easy to just have like mild out of the box settings, and then if overclockers want to break the CPU themselves, they can. That's the whole point of unlocked CPUs. You want to do dumb stuff with your silicon? You want to break it in 6 months? That's why you buy a K chip. But out of the box, the CPU should work. And it should work for years. Like any other CPU historically has. I can buy a 2500K today and it'll work just as well as it did when it like several years ago. Maybe it won't do like maybe that CPU did 5.4 gigahertz when it was brand new and now it only does 5.2. But like it still works at stock settings. So yeah, whereas like the i9s like even in a server environment like they don't work after a few months or a year. Like what a massive fail. So, yeah, I mean, I guess that'll be it for this video. Because there's nothing more I really want to say about this. Like this whole situation is just like this is so freaking stupid. Like you didn't have to ship these chips at freaking 6 gigahertz. And I am really like I am still convinced that this is just a voltage thing because otherwise this chart would look very different. It would, instead of being primarily i9s, it would be whatever 13th gen or 14th gen CPU is most popular. And I kind of doubt that the 13900K is the most popular CPU, but it is the oldest high voltage i9, right? Like it runs high voltages and it's older than the 14th gen chip. So yeah, there's going to be more of these in bad condition than there are 14th gen chips. Um, that's then followed by the high voltage, the because 13700K I would assume is lower voltage than 14700K on average, slightly, because it runs slightly lower clocks. Because yeah, between 13th gen and 14th gen, the only thing that changed was that Intel raised the damn voltages. Um, Which seems so stupid if like these things are degrading. Like these chips are degrading like so fast that like literally Intel could have tested for this by just putting retail chips in a freaking warehouse and running them on like regular consumer motherboards. I mean, I guess if they did that and they found out, hey, these things are falling apart, they probably wouldn't go and tell the public about it now, would they? Yeah, that would probably not be a good move to be like, hey, yeah, we've been selling you broken ass CPUs for like the last year. Um, we have like a warehouse full of them that we degraded in like 6 months. So, yeah. Anyway, there. Now I'll actually press the stop button. Right, there's like links in the video description if you want to support the channel. Sorry for wasting your time with this rambly, disorganized rant, but like this is just so disappointing. Like we could have just had a fun overclockable generation, but no, we had to push it to 6 gigahertz. Um that's the other thing is like these chips don't even have any overclocking headroom because Intel redlines them this freaking hard. Um Like, as an overclocker, I would honestly prefer it if it shipped at 5 gigahertz and overclocked to 5.5, because then you at least can say, oh, yeah, I actually achieved something. But as it is like, no, I buy my 14900K and then I underclock it so it doesn't destroy itself. So, anyway, I'll stop wasting your time at this point and actually press the stop button. Thanks for watching, and goodbye.